Okay, welcome to the video for 2C. As you can see, this video is looking a little bit different already because I left my little tablet at home that I write with. So I had to be creative and try a different way. So hopefully this will work out. Anyway, objective 2C, I can simplify an equation using the distributive property and combining like terms. So first let's get down some vocabulary here. Okay, so term is part of an expression separated by a plus or a minus sign. And we're going to find all these things in this expression here in just a little bit. But let's get all this down first. So make sure that you're pausing the video, writing it all down, and rejoining me so that you're not writing when I'm talking and going over things. Okay, next we're going to write down what a constant is. A constant is a term with no variables. Next we're going to write down what a coefficient is. Okay, a coefficient is the number being multiplied by the variable. Next, we're going to look into what like terms are. These are terms with the same variable to the same power. Okay, and last here, the distributive property. And for the distributive property, make sure you have everything written down, and then, so if you need a pause, and then join me again. For the distributive property, I'm not going to use words, but an expression. So the distributive property just says that if you have A times the quantity of B plus C, you can distribute that A like this. This is multiplying with the parentheses, so it's A times what's in here. You can distribute by multiplying it to each of these terms. So this would be equal to AB plus BC. Okay, so coming down here, identify the parts in the expression. Okay, so what is a term? Let me get out some colors here. A term, each of these is a term. So we have the parts of the expression separated by a plus and a minus. What is the constant? What is the constant? Well, the constant is a term with no variables. So let's look. This one has variables, it has A and B. This one has variables, it has A and B. This one has A. This one is the term without any variables. So that's the constant right there. Next, what is the coefficient? What is the coefficient? Here, let's get out a different color. Well, it says the coefficient is the number being multiplied by the variable. So here are our variables. So what's the number being multiplied by the variable? Well, 4 is the coefficient in this first term. 3 is the coefficient in the second term. And 5 is the coefficient in the third term. And then this again is just a constant. So it's not a coefficient because it's not being multiplied by some letters. All right, then we're going to look for like terms. Are there any like terms in this expression? So we need terms with the same variable to the same power. So AB with B being squared would not be the same as AB because these are both being raised only to the first power. This is to the first power if there's nothing there. So while these kind of look alike, you can't add them. It has to be the same power. Here, this one has an A, and these two both have AB, so it has to have exactly the same variables in there. And then this last one has no variables. So are there any terms in the expression that are like? No, there are not in this one. All right, identify which terms below are like terms. We do so by using different symbols. So one of the tricks I use, and we'll use it later on when we're actually figuring out or simplifying some problems, is a different symbol. So for instance, let's put a square around anything that'd be a like term with 3x. So as I scan down here, I'm looking for anything with just an x in it. So 8x would work. Keep going. And that's the only one I see with just x in it, to the power of 1. So now I'm going to use a different shape. So negative 5x squared. Now I need to find something with an x to the power of 2. Notice I didn't put the same shape around these because this was a different exponent on it. So go down and find all of those with x to the power of 2. Okay, this one has x to the power of 2, but it also has y, so this isn't going to work. It's not a like term. So keep going. And that looks like it's it. All right, I'm going to use a triangle, XY. And you can pause and try to figure this out yourself, or you can watch me for a couple more. So I'm looking for x and y. Well, here I have x and y, but raised to different powers. Here I have x and y, but it's a negative. That's okay. It doesn't say anything about it having to be the same sign. It's totally fine for it to have a different sign in front of it. So this is like term. Okay, let's go with an upside down triangle for this one. Here's another one with just a y. That's it. I'm gonna do a heart. Starting to run out of ideas here. So x squared, well this is x, but it's the y that's squared. This is a constant because there's no variable. Oh, it looks like I forgot one here. So let's look. What does this one go with? Well, this goes with the squares. I forgot one right there. Okay, just because it's negative or because there's a 2 in front of it doesn't mean it's not a like term. I just missed it earlier. All right, back to the y. I do not see any other terms other than these two with just y in them. So I think I'm done there. X to y squared, put a little cloud around it. And I see one over here. There we go, and then our constant, and our constant. All right, so I've identified all the like terms. Now let's combine like terms in the expression below. So you just need to make sure that they are in fact like terms. X squared and x squared, they are like terms, so I'm just going to combine them using the sign that's in the front. So this is both, they're both positive, there's nothing here, and this is plus, so there's going to be 8x squared. And notice I didn't add up the exponents. We'll talk more about exponents in a later section, but you do not want to add up those exponents. You can only combine them if they're the same, and you just keep that exponent on there. So 3x minus x. Well, you can either think of this as 3 xylophones minus 1 xylophone, or you could also remember that there's nothing in front of that variable. It's like there's a 1 there. So we have 3 minus 1 is 2x. Okay, here I'm going to use that strategy again. I'm going to put a box around anything with an x. Make sure you get that sign that's in front of it in the box to remind you that it goes with it. And now I'm going to put a circle around the y's, and then the constants over there by itself. So now I can put my x's together. So negative 8x minus 6x is negative 14x. And then positive 7y plus 1y is 8y. So put those together. And now don't forget your constant. That was a positive, no, that was a negative. So negative 5. Okay, this is fully simplified. This is as far as I can go with this. I cannot combine these two because it's 2 different letters, and I can't solve for this or this either. All right, coming down here using the distributive property. So now we're just going to use what we've done up here. So I'm going to distribute this and this. So 3 times 2 is 6. Don't forget your x. And 3 times 5 is 15. They're both positive, so the 2 terms are positive as well. Right, same deal here. You just want to make sure that you follow your rules when you multiply by a negative. Negative 2 times 8 is, or I'm sorry, negative 2 times 4 is 8, so negative 8x. And then a negative times a negative is a positive 10y. Okay, coming over here, this is a really common mistake that I see even now with my pre-calculus students. You have to make sure that if you have a negative in front of something, you don't just drop the parentheses. So I'm going to show you this is not equal to negative 3x minus 5. What happened here is I just dropped the parentheses and just put the negative on the first term. So this is incorrect. What you need to do is make sure that negative is distributed and hits both of those. So we get negative 3x plus 5. Okay, now we're going to combine these two things that we're doing. The first thing we need to do here is distribute. So I'm going to distribute my 2, and I'm going to distribute my 3, and I'm going to be careful with my signs and make sure I don't lose anything. So 2 times 4x would be 8x. 2 times a negative 5 would be negative 10. Positive 3 times a positive 5 is 15. 3 times negative 2 is negative 6x. And now, just as I did before, I'm going to box and triangle my parts here. So this is going to go with this guy right here. So I have 8x minus 6x is 2x. And then these guys are like terms, they're constants, and I'm gonna combine them. A negative 10 plus 15 is 5. All right, this is fully simplified. Fully simplified. Okay, you cannot solve. You can't solve. A common mistake I start seeing is everybody wants to find out what x is. There's no way to find out what x is. The only way, and you don't have to write this down, but the only way you could have found out what x is if there was an equal something else over here. At this point, you could solve, but this, you can't solve. Okay, I've left 2 for you to try. All we're doing here is simplify. We can't solve because there is not an equal sign in there. You can't solve a problem that doesn't have an equal sign in there. All right, give them a try. Make sure you write down any questions you have for me, and we will go over this in class. Thank you.